making a video. I should be anyway. Draft physics and such. Magnetism will be the subject. And get to the right screen. There we go. Regarding magnetism. Give you a sneak preview. Anyway, so this is the big one in my opinion. Nobody's explained magnetism very well. I mean, if somebody has a favorite explanation somewhere of what the exact cause is, what's the effect, how does it work, where's the energy come from, is the big one. And clearly there's energy. I mean, I can take two magnets and bring them in proximity and they will forcibly repel or forcibly attract, and the energy for those movements is unaccounted for. People don't say bent space did it, and they imply something like a virtual photon, some sort of radiant energy, but they have no explanation for where it comes from, because the matter doesn't get burned. The energy doesn't come from the battery that you might think the magnet was. It doesn't run out of magnetism. No evidence that it expends anything to create this energy. No solar masses lost in the conversion. Kind of a joke about gravitational lensing. Only the sophisticated physicist will get that one. Anyway, so let's play. So what is magnetism? So I'll give you the simplest and the most complete answer ever produced. Just a fact. If somebody, like I said, has a simpler and more complete explanation they wish to link me to, please do so. And explain whether it's simpler or whether it's more complete. Yeah. Alright, so the first step when you look at a magnet is, again, find the energy. Where does it come from? You're saying bent space really isn't going to work. So what's doing it? It has to be some kind of radiation, has to be a force, has to be something moving, and we kind of know that it moves the speed of light. So I mean, that's not entirely a giveaway, because bent space is supposed to move the speed of light, and so is photons and the rest of the electromagnetic spectrum. I think that covers it, right? Yeah, charge. And charge comes up in this conversation, of course. So the first step is find the source of energy, and I fell on that by starting with a source of energy for gravity instead of bent space. So in a sense, the explanation for gravity is the explanation for magnetism. You won't find the explanation in the quantum world. You'll find it in the what makes gravity work, and it's the same force, it's just that the force has a catch to it. So anyway, so the first step is doing that, and for me that happened because I didn't I said, well, let's say that they're wrong in their diagram of the universe. Alright, so incorrect current theoretical assumptions regarding the function of other elements of the universe break the energy source chain. So I would argue that people should have never accepted Einstein's explanation without some kind of definition of how you generate the energy. Just because it's in its local network conservative, that is, it takes as much energy to get out of gravity as gravity gives you to go into it, doesn't mean you can say, I don't need to account for how it works. And we clearly see that in the real world, gravity is almost forever in the sense of its influence. Just like photons, it travels great distances and still affects things at great distances. And so it should never, that was just a huge mistake physics made, was to accept an explanation for gravity that was way too undercooked, way too simple, let's say. It's not even that it's simple, it's just that there was no explanation for how it works. It's just like saying flying machine and then not having to account for how you make a flying machine. You just say, use the flying machine, but I don't have to build one for you. It's but that's the first mistake. So the energy is in the universe. I'll give away another secret that's in here. It's a push universe. Okay, the force comes from the outside, and all the magnet does is filter. So that's the next statement. The magnet should be seen as a filter, not a source. So clearly there's no way to make the magnet into a source, because we know I can have a magnet for thousands and thousands of years and it's magnetic. It just sits there being magnetic. You know, it can be just stuck to something for 1,000 years, and the energy just doesn't run out. So it's not burning something. It's not converting anything. Well, converting is the wrong word to use in this case. What it's doing is like a polarizing light filter. It's taking stuff that's one way and saying you go this way, and it's taking stuff that's another way and saying you go that way. It's segregating a force, and that's the simplest way to describe it, is that you can't do it with some idea of, well, the magnet only lets a little bit through or a lot, because it has to be something, the inverseness of the strong attraction between, say, two protons, and the strong repulsion between the strong repulsion between two protons, and the strong repulsion between two electrons, and then the inverse effect of their strong attraction. It means you can't use just a linear force and say, well, you blocked half of it, or you blocked 90% of it. It needs to be something inverted, something where you're changing the percentage of something that has two qualities to it, like vertical and horizontal, like polarization. It can't just be a linear thing where magnets change, you know, just reduce pressure, because that wouldn't explain the repulsion. So anyway, next, second step. Okay, what was the first step? That was way back here. Find the source. Yes, the energy source. Recognize there must be two kinds of energy. So that's, you know, that's when it all fell into place for me, is when I first came up with 3 kinds, which was a mistake. And then I realized I didn't need the third, neutral. I had a neutral kind to do gravity. But it does do gravity because the effect is always inverse. So the idea is that if the force is affecting electrons more and then affecting protons less, the total amount of force will always be equal to what gravity would create. So the excess of reaction of the repulsion, let's say, between the electrons is inversely related to the excess of reaction of the attraction between the electron and the proton. So it'll always balance out, so you don't need any third element. Alright, magnetism is a derivative of charge. So I mean, once you've established that there's 2 kinds of energy, it becomes kind of obvious saying, well, north-south is really plus, minus. It's the only sensible way to look at it, really. You know, and you know, and it just fits into charge, and you just say, okay, well, the proton and the electron are essentially the magnetic monopoles, and we can't create out of big stuff a true dipole because it's big. So little dipoles can do things that big dipoles can't, and so they think there's no such thing as a magnetic monopole, but there is, and they're in the form of the electron and the proton. And so magnetism is just a derivative of the fact that electrons and protons have positive and negative charge. That's what creates magnets. Just putting one of those charges on one end and one on the other end, and now you now have a magnet, because they're doing the magnetic function when they're independent as charges. They're still functioning as a half of a magnet, in the sense they're doing half of the polarizing. So it's like the difference between putting one polarizing filter and then putting 2. You can do a lot more if you have 2. Alright, so electrons and protons can't make the 2 opposite reactions out of one form of energy. So it's another way of just supporting the idea that you can't do this. You have to somehow create the positive and the negative. So you either create an artificial ground and then have positive and negative, or you have to do something to create the 2 distinct elements. and that's all you really need. So to explain magnetism, all you need is these four players: the proton, the electron force bit, and the proton force bit. The interesting fact is photons, light, is the electron force at a frequency. That's why it primarily affects electrons. Alright, the two actions of charge. So we know there's two effects you get from charge, which is attraction and repulsion, which is just so obviously similar to the effects of magnets, which is attraction and repulsion. So you can really see that the two have to be understood as just derivatives of each other. Reflecting and therefore absorbing versus diversion without absorption. So this is basically the fundamental function, is that the electron force reflects off of electrons, that is, it hits it and bounces off, in the sense that the momentum goes into the electron and it moves, and it expels, because of Newton's law, it has to leave something behind. It expels a little bit going the opposite direction. So a bit going this way stays in, and a bit going that way comes out, and then the net electron has lost something going that way and has gained something going that way, which is momentum. So the electron moves. Now, if the proton force hits the electron, then the electron diverts it in one of the four 90-degree planes, tangents, perpendicular. So the energy isn't absorbed by the electron. So if the proton energy hits, it isn't absorbed, and it leaves in a benign direction. That is, can't possibly be reflected. So the key thing to understand about reflections and repulsion, this is how repulsion is created, is that something goes in and it doesn't come out. So it continually reflects back and forth, and that's pressure. So then that's why when you bring electrons closer and closer, they get more and more repulsive. Just like a magnet, you're doubling the pressure as you have the distance. The pressure gets stronger and stronger and stronger, proportional to the fact that it's trapped between the magnets reflecting, and all the red energy is leaving perpendicularly, which is the same as understanding that if it has a way of knowing which direction, it can choose which perpendicular direction based on circumstances. But clearly that's what's happening with a magnet, is the energy comes in mixed, proton and electron energy mixed, and the electron energy comes out this end, the proton energy comes out this end. Any electron energy that hits this side reflects, which is the same as coming out, right? Any proton energy hits this end reflects, which is the same as being redirected. And so basically it's all electron energy coming out of one end and proton energy coming out of the other end. Now the strength of the magnet will depend on how well it does that filtering, how perfect the segregation is. So achieving perfect is probably far from our reach. So might as well go to the picture for this. Just it's a better illustration than my in the air battery thing. So clearly the force comes in mixed. So just think of the red bits as the red pieces of momentum: cannonballs, bullets, perturbations, ether, corpuscles, however you want to think about them. They're things that can impose momentum, and they're moving the speed of light. Bent spaceites, doesn't matter what you think they are, it's a hunk, a quanta of momentum. And when it's at a frequency, like I said, it's a photon. When it's not at a frequency, when it's random, it's not detectable because it doesn't affect electrons the proper way. But anyway, separate subject. So it comes in mixed, and the filter of each little atom in their dipole atoms, that is, the atoms of the magnet, as we already know, are made up of domains, and the domains are made up of a bunch of atoms stacked on top of each other: proton, electron, proton, electron, proton, electron. And what they're basically doing is all this idea of the protons are pushing everything, all the black energy up, and the electrons are pushing all the red energy down. And well, the image is exactly the opposite, but you get it. So they're just polarizing filters. So the strength of the magnet is really in the atmosphere itself, and all it's really doing is changing the pressure. And so this drawing might be more helpful for that. So as you get rid of the black energy out of one end, so say if the two ends of the magnet stick to each other, just like electrons and protons, because all the black energy escapes out the proton, all the red energy escapes out the electron, and nothing can reflect. And it's when you have the two facing each other like this, then you see that they would reflect. The electron force will reflect between the electrons, and as you bring them closer together, the reflections are more numerous. The force always moves at the same speed, so you're doubling the number of impacts at exactly the same speed. So doubling the number of impacts at the same speed is doubling the momentum, the force. So proximity doubles the force, and that's essentially how the magnet's working on the larger scale. By putting a bunch of those little magnets together, it makes a very big magnet that's going to do exactly the same thing as that little atom is going to do in terms of filtering the force that comes in. Okay, seems acceptable. Alright, so the two actions of charge, reflecting and therefore absorbing versus diversion without absorption. So you can think of it as a reflection. You need to think of it as a reflection that creates the pressure away. So when the magnets are turned upside down to each other, to the same pole, you can understand that all black energy is coming out of both of them, and they both reflect black energy. So you can understand that all the energy just keeps trapped inside of them. And so they repel each other. And the closer you bring them, the stronger that force. And when you do the inverse, and all the black energy leaks out the red end, and all the red energy leaks out the black end, then you're going to create low pressure, no reflections, therefore they'll move towards each other because of the external pressure, gravity pressure, the random pressure. Okay, so attraction is just the absence of repulsion. So you're just taking away the internal pressure, the pressure between two things, and the external world that's full of pressure, that's making everything in the universe round, that's pushing everything into each other. That pressure wins when you remove any reflections between things, because it's essentially being shadowed and gravity takes over. So gravity wins, okay, when two opposite poles are facing each other, okay, and reflection wins when two same poles are facing each other. And that's what makes magnets different, is the capacity to create the reflections. See, the Earth and the Moon aren't polarized enough for them to create some sort of inverse relationship where they could overcome gravity by capitalizing on these trapped energy, the energy that would run back and forth between them. Because all their dipoles are mixed, there's no segregation. There's no, you're just as likely to hit a proton as you are an electron, therefore you're going to lose your reflectivity. Alright, so it's a push universe, so that's what it turns out to be. Einstein was wrong. I know you don't want to know, but he wants to believe it. But yeah, it's just wrong, okay? There's no bent geometry. It's not a very good answer anyway. You should know that. It really shouldn't hurt you so much to lose this stupid notion of a pole universe based on a silly notion of a curved, a two-dimensional well in 3 dimensions. Doesn't even make any sense. It's a 3-dimensional universe. We see the spherical symmetry. It's push all over the place, and that's what it is. It's a push universe, and push explains magnets. Alright, just changes in pressure absorption versus redirection. So the whole universe just works on this simple idea that you create low pressure and high pressure, and things move from high pressure to low pressure. That's simple. If the wind blows, I got more pressure on one side than the other side, I tend to be pushed. It's just the same thing happening on the small universe, and the wind is a constant force that's generally speaking random until you become a player in a bunch of other objects around you. So other objects will influence, they'll create shadows, and those shadows of the pressure will change which way you'll move, which way you'll be pushed. And you're going to be pushed. You're never going to be pulled anywhere. There's no real such thing as a pull in the elemental universe. Alright, so that's the outline. Like I said, it's so simple that I really shouldn't have to go into a ton of detail. If you have any knowledge of physics, you understand this is a charged object here, and this is a charged object here, in the sense that that would duplicate what the negatively charged thing is doing, in the sense that it's obviously reflective to a force that annoys other black things. So the electrons are obviously reflecting something that annoys the other electrons. They reflect it back, and it just has to do with them just throwing the momentum back and forth at each other. And as they throw that momentum, they create pressure, and they tend to move if they can, if the pressure is stronger than the external pressure pushing them towards each other. And that's all there is. And that's why magnets can overcome gravity, is because gravity is creating a low pressure, and the magnet simply creates a counter high pressure to push against it. And it's that simple. But magnets are being affected by gravity. So you have to understand that whatever a magnet does to whatever it radiates to the rest of the world, it doesn't itself have to feel, unless there's another electron, right? The only way I can feel the force I emanate is if something reflects it back at me. That's the only way I can know I did something bad, or I made a change that hurt somebody. The only way I can do that is they have to reflect the swords or the knives back at me. And that's how the universe works. So I don't know if I can make a simpler statement. I don't see how anybody could say, hey, this can't be the truth, because it fits perfectly. The idea of it isn't that extreme, in the sense that we already know there's cosmic background radiation in all kinds of frequencies, and that why couldn't there be some more of that stuff that wasn't at a frequency? We have to admit we have no tool for measuring, okay, besides this. We have no tool that can measure anything on the electromagnetic spectrum, quote unquote, if it wasn't at a frequency. If we assumed that there was something on the electromagnetic spectrum, so to speak, that had zero frequency, or an infinitely high frequency, but let's go with zero. That is, it never gave you enough pieces in order. Okay, so it give you this much, and then the next one would be this far away, and then the next one would be this far away. We have no way to tune something that's not at a consistent frequency. So if it doesn't have little bits, enough nodes, if you want to think of it as a wave, if it doesn't have enough nodes, our detectors can't see it. It has to be a certain minimum number of nodes of the wave, if you want to talk in terms of waves, and if less than that show up at a particular frequency, we can't recognize it. Our eyes can't do it, but they need 6 or 7 of those nodes, and we don't even have instruments that can detect tiny little pieces of frequency. If we try to tune a photo detector to do it, it just picks up all kinds of noise. And guess what that noise might be? That noise might be gravity. So we know that the cosmic background radiation exists. We know that we're sitting here right now getting bombarded by all kinds of microwave radiation, cell phone crap, radar from some ship in the ocean. All kinds of radiation is hitting us all the time, and we're completely unaware of it because there's a balanced amount of it, and it's not strong enough to push us over. And all you have to accept is that there's a lot more of that than you thought. And how could it matter? You can't perceive it is in the form it's in now. So it doesn't hurt your imagination much to say, well, go ahead and double it. Double nothing is nothing. Triple it, quadruple it, times 1,000,000. Who cares? No effect is no effect. And that's the truth of it. You only have an effect when there's an imbalance, and then you'll feel it. So you do feel gravity, and that's exactly what I'm saying. That's the force. You're feeling it, you're sensing it, you're detecting it. You just don't know it because you've assumed that force was something other than a real force. You've assumed that it's some sort of, the earth is calling me, or, well, that's what most of you think, right? Somehow the earth has told my atoms that they must move down for whatever reason. That's your explanation. I'm sorry. I mean, I don't know how to even describe the current model, because the current model is so silly, because it doesn't tell us why my atoms, every single one of them, seem interested in going down. Why do they want to do that? What's making them do that? You know, without a force, it seems kind of silly. It's just having things, it's spooky action. I mean, it's ironic that the man so famous for the line spooky action, I mean, Ben Space was a spooky action theory. It just says absolutely nothing about how it happens. And that was a huge mistake to accept that empty answer. Because if they wouldn't have accepted that empty answer, and if they would have kept thinking about external forces perhaps making gravity push, then they might have just figured out this simple answer for why magnets work and where the energy comes from. Again, where does the energy come from? You have to have a source external to the magnet, because the magnet doesn't shrink, it doesn't get hot, it doesn't burn anything, it doesn't change chemically, it doesn't do any of that. Unlike radioactive isotopes, the matter inside of a magnet is not decaying. Okay, it's not converting into some other cells. It's not doing any chemical. It's not creating any chemical energy. It's not doing any. It's nothing like a battery, and yet the energy it has is clearly obvious. All right, so I think that's all I can do for you. I don't know how this can possibly be resisted, as I don't know how you can escape saying, yeah, that's so simple, it's got to be the answer. I mean, it solves the problem, it explains the whole thing, attraction, repulsion, explains how, yeah. I just don't know how you can escape just saying, good job, Gary. How do you do that and call yourself intellectually honest? It explains magnetism. Show me. Again, link to me. Anyone who thinks I'm an asshole or a jackass or a crank or an idiot, well, just link me to the better explanation of magnetism. Go ahead. Is this the simpler one or the more complete one? This will describe every single thing a magnet does. And of course I could explain to you how an electromagnet works by just aligning all the little atoms and therefore creating a filter. But it's always the filter that's doing the work. Well, not always. Okay. When you have an electromagnet, what the electromagnet's actually doing is some of the energy radiates from it, the electrical energy, and it's actually magnetizing the substance that the magnet comes in contact with. So it induces in the other substances a likewise strong magnetism. So it can spread the magnetism using the electrical contact through the metal, like a transformer. So there's induction, a lot more induction involved in an electromagnet. So an electromagnet can be made stronger. It can pull more wattage to lift more metal, let's say. Where a regular magnet only has so much lifting capacity and that's all it has. So with an electric magnet you can force more force through the domains. You can put more of these little black and red things into the magnet and have them filtered. Okay, yeah. So, but you know, I'm just saying each subject I can give you more detail. But just as a simple point, as an argument in defense of a theory, like I said, there's just nothing you can imagine as a part of real physics that this explanation doesn't fit. That was enough pleading. Just so obvious. And like I said, if you're saying no, you're saying it for not a good reason. That's all I can't imagine a good reason to say no, that's not right. You can't have a good reason. Not possible. That's my claim anyway. Not possible. Alright, so we'll call it a video, and so till the next time, and such.